All right. Hey guys, this is Mrs. Lyons, and we are going to work through the mole to mole conversions homework in your packet. So let's get going. Again, every time we do any kind of stoichiometry calculation, the first thing we have to do is balance our equation. Okay. So if I look at this, I can count. I only have one oxygen here. I have two over here. So I'm going to put a 2 here. That gives me 2 times 2 is 4 hydrogen. So if I put a 2 here, my equation's balanced. All right. So if 24.86 moles of water are produced, how many moles of O2 were needed to react? So my given is 24.86 moles of H2O. Now, once you get used to this, I don't care if you write the given and unknown. I'm just doing it so that as you're learning, you can go back and look and I can kind of explain where the things come from. So we're looking for moles of O2. So again, my mole ratio that I'm going to look for would be moles of H2O. So 2 moles of H2O to 1 mole of O2. All right, so I'm going to put down what I'm starting with, 24.86 moles of H2O. It's my given, always over 1. And then my conversion, I'm going to have 2 moles of H2O on the bottom and 1 mole of O2 on the top. So when I go to calculate this, I'm going to do 24.86 divided by 2. And I get 12.43 moles of O2. Okay. Number 2, if 8.63 moles of H2 reacts, how many moles of H2O are produced? So my given is 8.63 moles of hydrogen, and I'm looking for how many moles of H2O. Okay, so my mole ratio, I'm going to abbreviate MR, mole ratio, is moles of H2. 2 moles of H2 will produce 2 moles of H2O. Okay, so let's set this up. 8.63 moles of hydrogen over 1. And then I do 2 moles of hydrogen and 2 moles of water. Okay, now I know that this simplifies to 1, but I do ask you to put it in there so that I know that you got those numbers for the mole ratio from the coefficients of the balanced chemical equation. So this ends up just being 8.63 moles of H2. Okay. Let's see. If 15.59 moles of oxygen reacts, how many moles of water, how many moles of H2 would be needed to react? Okay, so our given is 15.59 moles of O2. Our unknown is moles of H2. Okay, so basically what we're looking at, just to kind of go back and revisit the idea of stoichiometry, you can do these kind of problems, can ask, it can start with reactants, it can start with products, it can have both reactants. Basically, it's a calculation that says, if I have this much of this element or compound, how much do I need to react? Or if I react this much, how much do I produce? Okay, so that's kind of the thinking behind this. Okay, so our mole ratio here would be 1 mole of O2 to 2 moles of H2. All right, so 15.59 moles of O2 over 1. We have 1 mole of O2 and 2 moles of H2. Our units cancel, so we do 15.59 times 2, and I get 31.18 moles of H2. All right,